So, welcome to our exciting online event, Introduction to Docker and Kubernetes, featuring our esteemed speaker, Mohit Chabra, who is Cloud Operations Manager at Confit. And I'm sure that you will find this session very interesting and very informative. So moving to who we are and what we stands for. So we are multi-cloud for you. We have a community of more than 100,000 strong technologists from all over the globe. And we specialized in multi-cloud strategies, data science, artificial intelligence, blockchain, and extreme engineering. Is my screen is visible?
No.
Yeah, my screen is visible.
Explain act is visible.
So we have more than 100,000 strong technologists from all over the globe, and we are specialized in multi-cloud strategies, data science, artificial intelligence, and blockchain, stream engineering. And additionally, we assist technologists in sharing their learning and accessing opportunity through our platform, which is www.fifthia.com. Now I'd like to give a short intro about how our company is growing. And so we have conducted more than 1,000 plus sessions till now, and we are having more than 300 plus speakers and 29,000 more than 29,000 members associated with our platform. These are the few of our master mentors who are associated with our platform. So we are also an academic partner with Alibaba Cloud, and these are the few courses that we have done in line with Alibaba Cloud. And you can go through all these courses on our platform, which is www.fifthia.com. And you can also get the certificate directly from Alibaba Cloud. So how we help? So we can help you to build your knowledge in digital presence and assist you during odd hours when you are looking for jobs through our community. And multi-cloud for you is a global data consulting and digital business transforming firm ranked by CIO Tech Outlook among the top 10 digital business transformation consulting startup in India. And you can get all of these with a single link, which is www.fifthia.com. So now, as a part of our community, we will provide a certificate to all the registered participants, and the certificate will be issued from our side within 1 week. Attendees who are not registered for the event, so I request you to please register for the below link, which is www.fifthia.com. I will also ping in the chat box. Yeah, this is the sample certificate which you all will get after the completion of this event. So moving to the speaker of the day, who is Mohit Chabra, who is a cloud operations manager, architect, and Microsoft MVP for Azure Cloud Operations at Confit. And Mohit is also a Azure champion, Windows 8 ambassador, Mozilla student representative, and a digital squad ambassador, and a hackathon winner. His expertise spans across the cloud operations, architecture, and many more. So for more information about Mohit Chabra, you can connect him on the social media link, which is given on the screen as well. You can note it down. Over to Mohit Chabra. Thank you. Welcome, Mohit, for coming on our platform. You can start with the session.
So without taking a lot of time ahead, let's start with the actual session. So Thank you. A bit of background about me. So my name is Mohit Chhabra. I work as a cloud operations manager at Configate in Germany. I take care of this global department, which is responsible for managing the SaaS system. So our job is to make sure that the application is up and running 24 across 7, and it's scalable, it's performing, and at the same time, it's secure. This background is important for this session because I'm going to give you more details about what are the challenges that I face as a operations manager as well, and how Kubernetes or Docker can basically help us out in managing it going forward. So, before going into the whole issue about Kubernetes and Docker, I want to start with a story. So, when I started as a developer, and at a later part of my career, I moved to operations. So I've seen the best of both worlds. So what used to happen is when I used to develop the application, that when we are going to give it to the operations guys, they say that, oh guys, it's not working. It's not working on the server. But when we were trying to reproduce that program, we were not able to reproduce it, and we always used to say that it's working on my machine. What does it mean? That developers are not able to reproduce, but we are getting surprises when we are moving towards the actual hosting of the systems, and it becomes very challenging in general as as we don't know what we need to do in order to make sure that the application is performing when it's going to the when it's going to the server, when it's going to the production. So there was a big gap. There was no one who could understand the language of developers in operations, and there was no one who could understand the language of operations in development. So then there was this bridge that needed to be done. That that role was developed, and it was called DevOps. And the whole methodology of DevOps is important because operation guys used to say that I understand, guys, it's working on your machine, but we cannot ship your machine to the customer. What does that mean? That basically means that there is something in the developer's machine that is enabling the application to work seamlessly. However, when we are pushing it to a production server, when you're pushing it to an actual customer environment, in that scenario, the application isn't working the same way. So there is some sort of a dependency. So someone thought, okay, we cannot ship the actual developer machine to the customer, but maybe we can ship the environment of the developer to the customer. And then the whole concept of containerization and Docker became popular with that. So what does that mean? So when you're working as a developer, you have some sort of dependencies installed in your local machine already that enables you to basically run that application. It comes as a prerequisite. And often and not, the big prerequisite are captured, but the small prerequisite that you have in the application are not captured in the same way. So what we do as a developer is we take note of all the prerequisites that we know that we have installed additionally on our machine. For example, if you're building a .NET application, then you have .NET framework as a prerequisite for that application to work. However, when you are installing Visual Studio, for example, as an IDE, it also installing some of the dependencies underneath for it. But in an actual customer environment, you have nothing in it, right? It's a vanilla system, it's a vanilla server over there. So you need to make sure that you have those dependencies in your local machine as well. And you identify them and you package them in a way that we can ship and it can run anywhere. So that was the challenge that we were trying to solve. And then the concept of container came in. So the whole concept of container has been there in Linux since long, but it became popular in a recent while. And I'm going to talk about that, what happened that made it so much popular as well. So what are containers to start with? So containers are nothing but it's a lightweight virtual machine. So you have been hosting your applications in a virtual machine where you have hyper virtualization setup, and you have underneath a host operating system. Let me tell you what it means. That normally what happens is that you buy big servers, big rack servers, and then you basically create hyper virtualization on top of that, and then you host different applications or website on that. So underneath the actual infrastructure is shared, but there you have a logical hyper virtualization on top of it to segregate these applications or these servers. So you basically create multiple servers under one server. That's the whole concept of hyper virtualization in a nutshell. And if I have to go in details, I can spend 30 minutes talking about hyper virtualization in general. But on a very high level, that's the idea. Then on those hypervised virtual servers, you need to put in guest OS as well, because underneath you have your actual server, which is running an OS, let's say Windows. Now on a hyper virtualization, you can create your Ubuntu servers, you can create Windows servers, so on and so forth, right? So you have a guest OS on top of it, where you have kind of a virtual servers enabled on this actual hardware underneath. And then you have the libraries, which is your prerequisite, which is the dependency that you have for hosting your application. Then the actual application code as well was hosting in the virtual machine. But then we realized, okay, what do we actually need in order to ship this application to the customer? Like, okay, yeah, we need some operating system to run this application, sure. But apart from that, it's only the libraries, the dependencies that we have, and the actual application code that we need to ship it through. So, so this Docker or container basically came into the market, and it's like a light version of hosting it in a virtual machine. It's a self-packaged container that you take, and with this self-packaged container, what happens is that all the dependencies that you need in order to run an application is stored and packaged together in a one place. If you understood this much concept, I'm fine with it. You will understand a bit more when I proceed further with the concepts of Docker and Kubernetes. So container has been there. The whole concept of container has been there since long. But what happened that it became so popular and everyone started talking about Kubernetes and Docker in the industry, and the whole industry moved to it? That happened because of a company called Docker. So Docker is a company who came in, who identified this program and used the concept of containerization to solve the issue that we had between developer and operations, that we often had surprises in the production system. So we tried to package it together with containers and then ship it. So Docker became popular because there were other companies as well who were trying to solve this program, but Docker basically streamlined the whole concept of containerization for you. So it's the leading open source containerization platform that we have in the industry right now. It does not matter whether you work in the Microsoft technologies, whether you work in open source technologies, Java, so on, Python, it doesn't matter, right? So the whole concept of Dockerization in general is same for all the industry, and it became an industry impromptu saying that anyone working on containerization basically started using Docker around it. I work mostly on Azure, and as you know, I'm a Microsoft Azure MVP for last 6 years. So I've been talking about Dockers and Kubernetes and Azure in general. So my session would be slightly inclined towards Azure, but I will try to make sure that I keep it as general as possible throughout the whole 1 hour that I have. So talking about the Docker architecture, so you need to understand three concepts in the overall Docker architecture. One is the client. Client is nothing but the machine who is basically in talking to the Docker host. What Docker host is basically a container engine that you basically install on a server, a Docker server where you want to basically run these applications on. And registry is basically storage, a repository for your images. Think of it as a GitHub, like when you're developing your code. So you're developing it from your local machine, that's just client. Then you push it to, then you use Git. That Git can be installed on a remote machine or your local machine, and then you basically use that Git to manage your code, and then GitHub is basically your registry where your code is stored. So because it's nothing but a binary file, like it's a target file that we create as a part of the containerization. We basically create layers of containers underneath, and we create one package that is used to build up an application. So we need to store it somewhere, right? So you cannot put it in a local machine. We need a centralized repository to save it. And hence we have the concept of registries for it. So registries, we have the most famous one, of course, is Docker Hub. It's managed and operated by Docker, the company Docker itself. Then, then we have GitHub Container Registry. We have Azure Container Registry. Similarly, we have container registries in GCP and AWS, Alibaba, all these cloud platforms as well. But the whole concept of container registry, basically, all the whole Docker is not limited to one cloud platform or only cloud platform. It's a generic way of managing, packaging, and deploying your application. So it works well with your on-premises servers as well. So the whole idea is that because you're packaging all the dependencies that you have in an application and then shipping all those dependencies alongside with it, and not just the application code, you can run it anywhere and everywhere. You don't have to worry about installing those dependencies into your local machine. This local machine basically means a server or your local machine. So with this, the deployment becomes streamlined and it becomes independent of any platform. So you're not dependent on running Azure, you're not dependent on running AWS, GCP, Alibaba, Oracle Cloud, all your PL share meta deployments, if you understand the concepts of Docker and Kubernetes in general. So, so what happens is that the client basically interacts with the Docker host, which is running on a server, and then create these containers based on images. What are images? Images are basically the pre-built images that we create. It's a pre-built schema that we have already created, whether it's us or some of the companies that we have in the market. For example, let's say if you want to run a .NET application. So what is the dependency to run a .NET application? You need a .NET runtime. You need your application code, right? So your application code is your stuff, but .NET runtime is standard, right? So what you do is instead of building your own code for .NET runtime, you download an image for .NET framework, and then on top of that you put your code as well. So you buy your binaries is sitting on top of the .NET runtime, and then you basically have it packaged as one thing. So this is one of your image that you do, and then instead of using this instead of using this as as it is in your local machine, you also then package it together and then ship it as an image. So this image is your application image. And when you have to run it, let's say you have a developer and operations guy. What you're going to do is you're going to build up this image for us, and I'm going to pull that image down and then run it underneath. So now because it has the dependency, which is .NET framework in our example, and then it also has the application code, we'll make sure that it runs there anywhere and everywhere. So when I pull it as an operations guy and then put it on a server, it will just run out of the box for because we have created an image. Image is a replica of a working solution for you. So with that methodology, we made sure that everything works smoothly as well. So how do you interact with it? Of course, now you have a UI, GUI as well to interact with Docker, but you typically like to, if you're working on these technologies, I prefer to go through Docker CLI, so it gives you a lot of tooling to basically interact with your Docker images that you have developed in these previous step. So how do you run it? So we have this typical command line tooling to understand on how to interact with the container. How do we deal with the container in general? So we start with Docker. We tell the CLI to use the Docker command line engine underneath. And then you have a verb on what you want to do, whether you want to run it, stop it, start it, whatever, right? So we are saying in this example that you want to run -i, -t basically means that you want to run this in a interactive run this container in an interactive terminal mode, that you want to talk to your um, talk to your container. Then what container do you want to use? So you want to use an Ubuntu container. So you have a pre-package, as I mentioned, you have a pre-packaged containers in the marketplace, and you download them for free, but make sure you're only downloading it from a verified source. There are a lot of people who have built their onboard solution as well, which is kind of your open source solution. You can use their solution as well if you think it's fine. You have to do all your due diligence. But if you're just using vanilla stuff like Ubuntu or .NET Framework or Python, um, from in that scenario, just try to use it from a verified source. But if you are using some onboard capability, for example, someone has built a framework to manage Google Maps, and you don't want to start from scratch for it, so you can download that already and then build on top of it another layer. Let's say a GUI, because this framework basically can manage and make calls to Google Maps, and then you want to change the way it looks and the user interacts with it. So you can do that. There are a lot of open source images out there that you can use, but you will be responsible for managing the security around it. So make sure that you do all the due diligence accordingly. But if you're using something like Ubuntu, .NET Framework, Python, make sure that you are downloading it from the official source itself. And what it does is basically it see whether you have this image already in your local machine or not. If you do not have it, then it goes to Docker Hub and download from there, which is configurable. You can also configure it to download it from your container registry, the private container registries as well. So, and then you basically can run it from there as well. Before I go any forward, I want to just clarify one small thing about private and public container registries in general. So the private container registry is a registry which is behind an authentication mechanism, which is not visible to everyone on the site. So if we, let's say if you go to Docker Hub provides you the facility of hosting your own container images. But by default, you can make it public or you can make it private so that only you and your teammates or your associates can download them. So people with a valid license can download them. So it's authenticated, it's secured by the authentication because you don't want to open source the work that you have been developing, right, in your company, in your private project that you're working on. So if you want to open source it, if you want to basically make it available to anyone and everyone on the internet, then you basically put it on a public repository, else you put it on a private repository. Then you don't have to then stick to Docker Hub. You can go for something like Docker Hub, but also like ACR as your container registry, and then GitHub has its own container registry, AWS has its own container registry. GitHub has its own container registry, so you can host it anywhere. And there are multiple options in the industry, and pretty much everyone provides the same functionality. So there is no specific benefits of using one over another. Some of the common commands that we have with Dockers. So Docker run, as we just discussed, basically it's used to run an image in your local machine in the machine where you're running this command. Docker pull basically will pull the image from a repository to that machine where you're running it. Docker build is used to build a Docker image, and Docker images basically is used to list all the available Docker images that you have in your machine already. So when we said about one that it's going to look into your local machine and then download it if it's not available, right? So Docker images gives you the list of all the images which have already downloaded in your machine, or you have run it previously, or you have built it previously. So all the images which are stored in your machine right now. So these are images, but might be some containers which are running. So these images are pushed into a running container, and that can be identified with the Docker space ps command. And then we have Docker execute to execute a command into container. Let's say if you're running a Python container and then you want to run as command on it, you can basically use the Docker Docker execute. Sorry about that. You can use a Docker execute command in the container, and then you can when you interactive code with it. Docker stop, as the name suggests, it's used to stop a running container. So when we have these containers now, and we have multiple containers, we have hundreds and thousands of containers, it becomes very difficult because the whole concept of container became popular because of a concept that came in the market called microservice architecture. So what does microservice architecture mean before I talk about orchestration in general? So microservice architecture basically means that instead of running the whole application as one big monolith application, you divide the application into small chunks. So it's easier to manage for you as a company, as a department. It's easier for manage, it's easier to deploy, it's easier to scale, and it's easier to operate. Let me take an example. So let's say Amazon.com. So Amazon.com is an e-commerce website, but it's a big piece of code that we have. It's a very big application. So there are hundreds and thousands of developers who are working day in and day out to make sure that this application is working. So they are developing some new features and functionalities, so on and so forth, underneath this application, right? Now, if you have to manage, deploy, and release this application as a whole, it it means that you have to coordinate with these all hundreds and thousands of developers to release, to basically get them with their work simultaneously, and then build up a release and deploy the new version of the application. Which is very challenging because there are different teams working on different tasks and they have their own timelines to manage. And coordinating at such high level is a nightmare in general. Then if you want to scale this application, let's say you have this Amazon sale coming up, Big Billion Day coming up, so on and so forth, right? Whatever sales that Amazon, Flipkart, these kind of guys announce. We all know that we will have more customers on the application during that time. When you're talking about these sales, or when you're talking about, let's say, Geo Cinema doing an IPL match, there will be a lot more load on the system as compared to their regular workload, right? So we need to make sure that we can scale the application accordingly. But do we need to scale the whole application, the whole big Amazon.com to handle that load? The answer is no. So it depends on your business requirement. In an example of Amazon.com, you don't have to scale the whole Amazon.com. You have to scale few of the stuff that is commonly used, because identifying the right scaling is a big challenge in itself. For example, um, if you enable your servers to handle 2 million requests per second, and you only are getting, let's say, 500,000 requests per second, in that scenario, you are wasting a lot of capacity on the server. You're spending much more money than you should have. So you are not efficiently using your resources in that case, right? Similarly, if you have capacity for 1 million requests, but at the same time, 2 million requests are now coming, what will happen? Right, the application will not perform, the application will not be responding. So a lot of the users will basically use plus, and your business will take a hit. And doing these sales, of course, you cannot afford a downtime and you cannot afford a poor performance on the application as well. So what is the solution? The solution is to dynamically scale the system, and not the whole system, but scaling the individual component that needs to be scaled. For example, the example that we have been using around Amazon.com, in that case, what happens is that, let's say, add to cart is commonly used because people are constantly adding to cart when they are looking at these discounts on these sales. And then let's say payment API is used. So that payment API can be scaled. And similarly, let's say product view API, it can be scaled during the sale. Now, first of all, because these are developed by individual teams and they are deployed and managed individually, all these APIs and the need to manage this functionality, we can scale them up, scale up and down independently. And if there is any bug in the application, let's say the add to cart team basically have added a new functionality that is resulting in a bug. So we don't have to revert the whole application now because there is a bug in a critical bug in the add to cart API. What you do is we're only going to revert the add to cart API functionality. So that's the whole idea of a microservice architecture where you are chunking it down into a smaller pieces. Now what happens is that because you have chunked it down into a smaller pieces, now you have hundreds and thousands of containers lying around because you have so many teams, so many functionalities that you're supporting, right? And every team, every department is building up their own containers, their own images to use. Now, now that we have the flexibility of scaling and managing and deploying and reverting all these containers, all these images individually, it also comes with an expense of managing hundreds and thousands of applications now, because we are saying that it's a microservice architecture. Maybe as a user, you see it at Amazon.com, but underneath to operate, it's hundreds and thousands of applications that you have to operate now. So what happens is that everything is packaged in a container. So you're deploying it, managing it, but now you need a bigger system to orchestrate these containers, to manage these containers, to talk to and communicate to these hundreds and thousands of containers. So if you have one container, you can manage it through Docker CLI. But what if you have hundreds of containers, it becomes very troublesome to manage it from a Docker CLI itself. So you need an orchestrator. So what does orchestrator do? It tells this orchestrator basically tells um, the containers on how they want to behave and what they want to do. It's like a overvision. Someone is doing a overvision of the work that these containers have been doing. So that's the work of an orchestrator. So then with this orchestrator, there are many companies who tried to solve this issue. So one of them was Docker itself. So Docker came up with something called a Docker Swarm. Then there were DCOS. But the most popular one, which by far took the industry, and we got to a situation that it became go-to stuff, and no one is talking about DCOS, Docker Swarm, or any other orchestration engine anymore because Kubernetes has taken a big leap in the industry. So it becomes an impromptu setup for managing these Docker setups. And Kubernetes became more and more popular with time now. So at today's age, I don't even want to talk about DCOS Docker Swarm at all. I think Kubernetes is the only environment and the only setup that you should know and learn about. So in a very abstract view, on a very high level, we have been talking about shipping these containers. So take the same ideology that we have, that we are packaging these applications into these individual containers. So our containers are the individual services. We talk about microservice, right? So all these containers are individual services. Then your ship, which is carrying it, is the actual infrastructure underneath, whether it's the physical hardware server, whether it's server on the cloud. So you have a lot of Kubernetes services on the cloud platform. So underneath, it's nothing but virtual machines running this infrastructure. So that's your cloud infrastructure as a ship who's carrying it. But the engine over there who is managing it, the orchestrator who is managing the whole ship is the Kubernetes um, over here. So while this is running on the internet, so internet is your sea that you're browsing. It's just one ship that you're managing it over here, but with multiple services underneath. So talking about Kubernetes architecture. So Kubernetes has this master worker architecture. We used to call it master slave as well at some point of time, but this ideology remains same. The slave word, that slave terminology is not appropriate anymore. But the idea is it's a master worker architecture. So what happens is with master is that it has its API server, it has its control manager, scheduler, etcd. What it does, it manages all the systems on a worker node. Scheduler is used to basically schedule some of the repeated jobs or some of the stuff on these worker nodes. Then you have etcd, which acts as a configuration manager, where it stores all the configuration that you require the the system to basically work on. And then on the Docker, um, and then on these worker nodes, so there is a master and they are these workers. These workers have something called as kubelet, which helps in translating the stuff that master is saying to these worker nodes. So let's say if I'm the manager of a department and I have a lot of employees working in my department, I need to speak the same language so that they can understand on what I want them to do. So that kubelet basically does the translation for me in this scenario. So I'm the master, Kubernetes master, and I have these kubelets with all my employees, and they know how to get it translated. Now, under these nodes, you have different pods, which is running multiple containers. So I'm going to talk about these terminologies. If you understood it on a high level, it's fine. I'm going to come back to this architecture later part of the session when I am done with when I'm basically done with the explanations of these multiple terminologies that we have on the system. So what are the facilities, what are the features of Kubernetes? Kubernetes gives you some of the special features that we use day in and day out. So the starting with container replication. What does it mean? That we were talking about this Amazon.com and scaling these application up, right? These individual services up and down. So during the sale, we are, let's say, increasing the capacity on, increasing the capacity on add to cart or product view API or the billing API. But when the sale is over, right, what you typically do, you don't add more stuff to cart at the same pace, right, that you were doing it during the sale. But now you track your shipment. So shipment tracking API needs to be scaled because more and more people will be tracking and they will be curious to see that where is my package? I want to get hold of this package ASAP in my hands. So like most of us have lost patience now, right, with the short media format. So that you have to take that psychology from a user perspective and put that into your business logic as well. That how the psychology of an individual users affect the load on the system accordingly. So from that perspective, the shipment tracking would be used more frequently as compared to add to the cart after the sale. So post sales, right? You need to maybe scale up the shipment tracking API at a higher pace as compared to what we have on the um, add to cart now. So add to cart can come down and shipment tracking can be scaled up individually. But how do you scale it up? When we say about scaling it up, let's say one instance of that shipment tracking API needs 2 CPUs and 8 gigs of RAM. Um, so one option is that you can put more RAM and CPU into that one instance, but that becomes very challenging because even when you are getting hundreds and thousands of calls and millions of calls per second, that one instance, even though if it's really big instance, it cannot handle multiple calls at the same time very efficiently. So what you want to do, you need to have multiple instances of this. Instead of running one single instance of this container, you want to have hundreds and thousands of applications. Depends on your business rules and scenario, of course. You can run it with 2, 3, but the idea is that you have the capability of scaling it up to hundreds and thousands as well if it's needed. So what Kubernetes does is it gives you this also functionality of load balancing. So all the requests are coming to Kubernetes. Now Kubernetes master basically sees that which of the node underneath, which of the pod underneath is sitting idle, and it starts sending all the traffic to that ideal pod. So it's same as the manager. As a manager, what I do is based on the bandwidth available within my employees, I assign the new work to the one who has the most bandwidth out of all. It does not make sense to basically give more work to the person who is overloaded with work already and who does not have the bandwidth to complete that task. What will happen if I do that? Then the task will be delayed. So then I have to wait for a long time to see the outcome of that task that I've assigned right now. If you see it in the Kubernetes or a web server terminology, then if I assign the same task to an existing pod which is running already, then in that scenario, which is then the user has to wait for long time for that request to be processed. And the only thing which is worse than no application is a slow application. As I mentioned that we cannot have slow applications. You will not like to shop to a website which is very slow. Amazon.com is quite fast. Let's say if you build up your own website like Amazon, users will not be happy if it's taking forever to basically serve your requests. They will be out of the window soon. So you need to make sure that you can scale these instances accordingly. Similarly, if you are watching a live cricket match, this IPL season going on right now, right? So from a IPL point of view, will you pay a subscription fee, even though Geo is giving you for free right now? Let's say Hotstar was asking for a subscription fee, but if let's say Geo is giving a 5 minutes delay on the match versus Hotstar is asking for $200 per month, but it's giving you actually as live as possible, right? So from that scenario, uh, you prefer to pay for that instead of waiting for 5 minutes, right? Because you want to see the action live. The delays are not permittable. The delays are not manageable. The delays are not acceptable in the industry anymore. Excuse me. So what the Kubernetes does is it identifies that whether it has the right capacity um, to serve those requests to increase, and whether it does not have the right capacity, it basically adds more capacity if it's possible. But if it has the right capacity, then it basically sends that request to the pod which is sitting idle for you. Then when I'm running this, I need a capability of monitoring all these containers as well. So that's also functionality that Kubernetes gives me out of the box. And then health check. The idea of a health check is that let's say if a pod is not working fine, right? Let's say if one of my employees is sick, I'm not gonna add more tasks to that person because I know he's sick. He or she is sick. If an individual is sick, it does not make sense to give more tasks to that individual on that day when he's not working. So what this person has to do is to let me know that, hey, I cannot work, I'm sick today. And what I'm going to do is I'm going to replicate him out, push that task to some another person. Then we also need to see how much time we are spending on the performance and how much resource utilizations are there, which basically means that out of 100 gigs of RAM that I have in the cluster, which service is using how much, and then you can do some distribution as well. You don't want that one of the service takes all the logistics of your server. Let's say the tracking takes all the tracking API takes all the computing available, and then when people are actually trying to add to the cart, it has no computing available, and that is very slow. So you need to also manage the resource underneath accordingly, because even if you have all this dynamic scaling and stuff, you have limited resources, or you want to keep your application running a specific budget itself. So, and then you have this rolling update. The idea is that if you have a new feature developed, you don't want to push that feature to to all the customers at once. You want to see the reaction of the users and see whether that new feature is working fine or not. So you start pushing it to individuals, to the subset of the users instead of pushing it to all the users at once. So I will quickly go through basic concepts of Kubernetes. So node, what is a node? Node is nothing but a virtual machine which is running the workloads of your service underneath. So when the master is managed, so master is also running in a node. So in a typical setup where you have it with any cloud provider like Azure, AWS, they manage the master for you. So it's a managed solutions over there. But the node which is running with these kubernetes are managed by you from this Kubernetes setup. So nodes are nothing but the underneath virtual machine, and you can identify what kind of virtual machine that you want to run it underneath. For example, if you're running some sort of a machine learning workload, then it makes more sense to have a GPU machines than a CPU machines in it, right? So it should be a GPU enabled machines. Some node, and you can identify some of the workload which requires higher memory to process. Then you can identify the underneath virtual machines accordingly and make the right choice over there. But that is with the virtual machine, but we're not deploying it in a virtual machine. Remember, we are deploying in a virtual machine, but not directly in a virtual machine concept. We are deploying with a container. So what we do is we deploy with one or multiple containers together, and pod is nothing but a one basic deployment unit of deployment in Kubernetes. What does it mean? We took that example of running a .NET application, right? So the application code, your .NET runtime, all the underneath libraries, let's say you have a Redis cache, and then on a MySQL as well, right? So all those things um, are can be packaged in individual containers, but that are packaged when there is one image. So that's basically is your one unit, one instance of that application, the tracking API, that whatever dependencies that you have to run one instance is deployed together in one pod. So your pod can be of group of containers, and every container can have its own configuration as well. But in general, on a high level, the pod basically can have one or multiple containers. In our example, like the example that I've used, you can have your .NET framework, your application code, your Redis cache, so on and so forth into one pod. So it's all the things bundled together that you need to run that specific application. So all these containers within a pod are always scheduled and managed together. So what does it mean? That we say that it's guaranteed that it will be on the same node, that all the containers within one pod are kept together. It's not going to happen that out of one pod, if you have 3 containers in general, 2 containers will be running in one node and 1 container will be running in another node. So that's not going to happen. So we'll have all of them individually, and we will have all of them packaged and run together as one individual unit. So these, in our example, the combination of 3 pods are ran together as one high-level package. So when we deploy this pod, so every pod comes up with their own IP address. And normally pods are expected to be stateless. We don't want you to manage states because you want to have a maximum applications as possible, and then you want to spin up and delete these pods as soon as you want. So in our example, we want to make sure that you can spin up, scale up these number of instances and scale down as well at the same time. And that's only possible if it's stateless, where it's not managing any data underneath, which is linked to that running of the pod. So it's one individual unit which is running on its own. And as soon as it's working well, it can be killed and get rid of. Then we were talking about scaling concept in general, right? So the whole concept of scaling basically becomes important because what you do is you tell Kubernetes that you need at least X amount of services. Sorry. So you have a pet cough right now. So sorry about that. But the whole idea of the picker set is that you tell Kubernetes that you want to have X amount of instances running at any point of time. But also you can say that, okay, I need, let's say, 10 instances of this tracking API. But after this days, you can increase it up to 100 instances after the sale that we have been talking about in our example, right? You can scale it up to 100 instances at the same time. So from that perspective, it becomes um, very easy for you with this replicas set. What you do is you replica set, basically you tell Kubernetes, like for example, my managers basically let me know that I need uh, to make sure that I have X amount of employees working. Now, if one of my employees basically becomes sick for long term, that I identify that he cannot work, or an employee is going out on a maternity or paternity leave, but I need to make sure that I have a specific amount of capacity in my team at any point of time, then I will have a replacement for that person during that period. So similarly, that's the same idea of replica set as well, that in this example, we have three replica sets. So at any point of time, we will have three instances of the replicas with us. But if one of them died, one of them crashes, one of them have any issues with it, then in that scenario, it will be replaced by another one. So Kubernetes will make sure that these replica sets are always created, and it's automatically managed by Kubernetes. You don't have to monitor, you don't have to do anything manually. While you're deploying, you just mentioned that I need this three replica set, and then you can put some more conditions for scaling as well. We have concept of horizontal scaling, vertical scaling, and KIDA as well. That helps you with identifying this with your business logic as well, to make sure that you can scale as per demand, but at any point of time, the replica sets that you have mentioned will be available on the server. So you will have at least three instances of these application, these services running at any point of time. Then what you do is you have the concept of deployments. So what it does is it helps you managing the replica sets and the state transition of it, because you have, let's say, when you want to increase the replica set from 3 to 4 or 5. So you're not going to directly do it. You're going to do a new deployment with your deployment.yaml. And then with that, then you can mention that you're increasing the number of instances from 3 to 5. And then it will take care of that accordingly. So that you don't directly touch pods, and you don't directly assess these pods. You basically assess it via the deployments underneath. So if you make any settings over here, the deployment is gonna override those settings in this replica set, and it basically gives you the whole history of the changes that you have made in your application. Then the concept of services comes into the picture. So now you have your application running. These services are deployed on the Kubernetes cluster, but from that perspective, that's not enough. You need to expose these services. You need to expose the code out so that anyone else can communicate with this code. So the tracking API or that to cart API, someone needs to call that API and then communicate with that, right? But if it's just a piece of code running, but no one is able to communicate to it, then there is no use of it, right? So you expose it out as a service in Kubernetes. So let's say you have this these code running. Let's say the add to cart API is running in these three pods right now. But you see, you have these IP address. You're not gonna ask. You're not gonna basically tell your code to go to these IP address, because these will change and they can continue to change. If one pod dies, it's gonna be replaced with another pod, so that IP address will be changed as well. So what you will do in your code is you're not gonna access these pods directly. You're going to access these pods via a service. So here in this example, we are saying that access put this all the service basically to the service, all the pods which are running the web, where the role is equal to web. The request will basically go to these individual pods underneath. But when you're consuming, you're going to consume a service. You're going to consume these code from a service. But these services are only happening within the cluster. So if you want to consume it within the cluster, it's fine. Let's say internal application, a discount coupon application, for example, when you're hitting that discount, and then it's calculating some discounts in the background. So that can happen in the cluster itself. But if you have to expose it out of the cluster, which is available directly on the internet, that API, for example, whether it's a UI as well as that, the UI of the application, then you do it via something called as ingress, or a new concept has came in, which is also known as a gateway. So it's a gateway API that has came in. So you in Kubernetes, you can either use ingress or gateway for it. Ingress has been there since long. Gateway is comparatively, gateway API is comparatively a newer concept in the world of Kubernetes. It came sometime last year. So services are basically typically used for communicating within the cluster only, because it has this internal IPs to it. And you don't want to you cannot communicate to an internal IP, right? Because you cannot resolve it from outside the cluster. There is a possibility of putting a load balancer to your service and then see, but it's not recommended to use it in production. You can use it for testing purposes in your WS cluster, but ideally you should not put a load balancer or an external IP to a service, and you expose it via the you expose it via an ingress or a gateway API that is then consumed via the internet. So I will do a quick recap on the architecture. So your Kubernetes master basically is the one who manages all the workloads on these worker nodes. And these worker nodes will be running with multiple containers. It can be one or multiple containers in one pod, and it can run multiple pods based on the capacity of that worker node. And you have a Docker engine and the kube proxy running with it. Along with, we have kubelet. Kubelet is responsible for translating all these stuff communication from Kubernetes and making sure that the workers are working and then can communicate to the masters accordingly. So I understand there are a lot of concepts. If you are very new to the world of Docker and Kubernetes, it can be overwhelming to learn about these concepts. But the whole idea is, with great power comes great responsibility. Kubernetes gives you that power, and it also then gives you the responsibility of managing these resources accordingly. And it could be quite challenging to learn the basics and the terminologies and get proficient with the world of Kubernetes. But because it gives you so much of functionality and capabilities to manage, it becomes very important for you to learn it in this era of computing. So that brings me to the end of my session. I had this demo, but I'm pretty sure we are out of time now. We are already 11 minutes in, but I started late, so I consumed an hour anyhow. To make sure that because you have taken out time from your settled schedule, I try to give you the enough content to go back and then start learning more about the world of Kubernetes. But on a very high level, if I have to sum it up in the 30 seconds about the demo, like you can develop the application and then create an image from your local machine, push that to a zero container registry, and then run it in a Azure Kubernetes service. So Azure Container Registry is holding your images that you have developed alongside with your code, and then you are basically pushing it to a Kubernetes service, which is running these pods with these images for you. So that brings me to the end of my session, and yeah.
Participants, now you can unmute yourself, and if you have any question, you can ask here. Mohit, someone is asking questions in chat box.
Okay, let me go through the chat box.
Yeah.
Okay, I have a question about C group and namespaces. Yeah, I mean, sure. It's a bit high advanced topic for the session, but I can give you a very high level idea. So So C groups are nothing but a capability of managing these resources in a limited setup, basically, where you can define the capabilities of limiting the CPU on how much CPU and memory that you want to use for your individual services or in general as well. Whereas namespace is a logical grouping of these services. So let's say when we talk about these managing these microservices, right? So you're going to create an individual namespace for that. So there will be a namespace for tracking API. There will be a namespace for shipping and add to cart, so on and so forth. So you can manage, scale all of them together. So namespace lets you, uh, it gives you the capability of logically grouping these resources together, and then so that you can ship, manage, deploy all of them individually. Then I have a question about, will we get the PPT? Yes. So I'm going to share it with the coordinators here, and they will make it available for you. Then I have a question about key features of Kubernetes which directly benefits business operations. As I said, right, you understand the business logic, the sentiments of the users, and the business needs accordingly, and then you can scale and manage the backend operations accordingly with Kubernetes, because it gives you that level of flexibility and manageability across the whole ecosystem of your services. In our example, um, it's a business requirement to scale the add to cart API or the product view API during the sale, but it's a business requirement to scale the shipping API after the sale is over. So from that perspective, it's a business operation requirement, and it's a business need that we manage the systems accordingly. Similarly, that on the IPL example that I gave, we know that during the working hour, during the match hours, we will need more capacity on the servers, on the streaming services, and we basically put that accordingly. So in that scenario, streaming service could be one capability, but IPL could be a namespace in itself, and you can scale the capabilities on the IPL streaming itself at during that time. So let's say you have two matches going on. One is Delhi Capitals and I don't know, Punjab, as compared to another is RCB versus CSK. So you know that you will have more traction on RCB versus CSK, or RCB versus a Mumbai Indians, or CSK versus Mumbai Indians, as compared to Delhi Capitals versus Punjab Super Kings, right? So from that perspective, it's your business logic. You know that from a business point of view, you need to scale up and put more computing on the RCB versus CSK match as compared to the other match that is going on. So you can manage these operations accordingly. And then of course you can scale it up and down accordingly, but you want to make sure that it's your business which drives the it's your business logic which drives the computing underneath, and not the other way around. And then the second part of the question is about the certification. So there are multiple certifications that you can do, but if you're a beginner, I will advise you to go to CKA, Certified Kubernetes Administrator, and Google about it, and you'll get all the information about it. Any more questions?
Participants, any another questions?
Manthan here. Can you hear my voice?
Yes, Manthan, we can hear your voice.
Yeah, so what would you suggest like we should learn to get more of entire DevOps package, guys? So the type of skill set that you feel that we should possess to become an like highly professional DevOps guy,
Okay,
apart
so
from Kubernetes and these cloud
right.
services.
So first of all, you need to understand the whole terminologies of DevOps that I started with to give you a program statement why DevOps is important. But after that, from a tooling and certifications point of view, um, then you should learn about CI/CD pipelines. Git is very important. You need to learn at least one platform where you can do some sort of deployments over there. You should be able to manage these CI/CD the whole concept of continuous integration, continuous deployment pipelines. And if you know one, you will be able to jump to any other platform. Like overall, the overall methodology remains similar. Jumping on tooling is not that big of a deal, but understanding the basic concepts are. So it's a similar, like if you know programming, right? You will just have to learn the syntax of another language when you are moving from one language to another. But in general, how do you code, how you solve a program remains the same. Um, so from that perspective, Git, I would say, is important. CI/CD pipelines are important. Monitoring is important. You need to learn some monitoring tools, and then learning cloud is very important as well. I would say at this point of time, you cannot survive without learning cloud in general. Good thing about Kubernetes is that if you work on Kubernetes, you don't have to know a lot about whereabouts of individual cloud platforms, but it gives you the capability of running it anywhere. So you don't have to run AWS in particular, but there should be a good idea about different AWS services or Azure services where you're hosting this Kubernetes setup. So on a high level, I would say Kubernetes is a must in today's scenario. But apart from that, CI/CD, Git, and a cloud platform to start with.
Yeah, thanks.
So another question from Ahmed, is Kubernetes considered as hypervisor? No. So Kubernetes is not an hypervisor. You are removing the whole concept of hypervisors with the virtual machine and containers. And because you're using the containers over here, where you don't have any hypervisor, it's not considered as a hypervisor. It's just a computing engine. Any more questions? Okay. If we do not have any other questions, I will be still open for the questions on my LinkedIn. So feel free to connect to me on my LinkedIn and drop a message. Share your feedback on how did you like the session. If you disliked the session, how was it as well. I will be happy to hear it from you about whether the session was useful for you or not, and how we can improve as well in these sessions. Apart from that, if you have any questions about Kubernetes or cloud in general, I work on Azure, and Azure has been my go-to cloud platform. If you have any questions on that, I will be happy to answer you and guide you in that perspective. So my details were mentioned, but I will be about my vending, so I will be available on vending to communicate with you guys if you have any specific questions. Some of you might be hearing this session after it has already happened. So we'll be doing through the recording of this session. So still feel free to basically reach out to me and then ask your questions. I will be happy to answer them.
Yeah, thank you, Mohit. And on the behalf of the multi-cloud for you, I would like to thank for giving us such a wonderful and informative session. And I also like to thank all the audience for joining us. Thank you once again.
Thank you.
Yeah, can I ask one question? Sorry, I'm a bit
Sure,
late.
Mandan.
Yeah, it is a bit slightly off the topic, but like, how would you suggest like people like us who are trying to seek uh, opportunities abroad, like those who are living in India right now
Okay.
with our skills?
So there's, I will tell you, there are two options. One option is to join a service-based company and then basically look for an on-site opportunity, which may not require the same level of skill sets, but it might require you some luck. You have to be at the right place at the right time. You might have to have a good relationship with your manager, which does not basically means that you are the highly skilled person going on site. If I have to be honest and blunt about it. The other option is to develop the skills and develop it so good that people from outside India basically they want you. That has happened with me. So when I moved to Europe, I was contacted by the CEO of the company directly through my LinkedIn because of my because of the presence or basically the kind of work I've been doing in the industry, and They directly reached out to me without an interview. We just had a conversation and they offered me a job and then moved me to Europe. So there are two options. Either build skill sets so powerful that it's very difficult for them to find an alternative of you, or be at the right place at the right time. Third option is also there, like you can go for higher studies as well. So if you basically go for higher studies, and there are some countries right now giving you a job seeker visa as well, but you will be only able to get a job outside if you have good skills. So work on your skills is what I'm going to say. Second is join a company where you have this on-site capability. That's another option that you have. A third one is a bit more expensive, where you have to spend more money on yourself, is by going to a higher education in a country you want to settle in.
Yeah, thanks. That's helped a lot.
Thanks. We are way over the time right now. So thanks all of you. Thank you everyone for joining, and thank you for listening to the end of the session. As I said, I will be available on meetings. If you have any question, feel free to reach out to me. Thanks once again.
Thank you.